Let me start by showing a couple of GitHub's repos that I will talk about now. So the first sample is called Qt Traffic Light. I will send you these links shortly. So it's here under HL Tech Software. And this shows how you can integrate your real-time application with a user interface that in this case is developed using Qt, but the principle is the same if you prefer some other UI framework. Let's switch to the tool. So here we have the traffic light demo. So some of you may recall that we have already a web-based version of this sample where the UI is a web page. It's actually exactly the same example we have taken, but we have replaced the web server with a Qt user interface. So otherwise it's exactly the same. There is a traffic light that can circle between the red, yellow and green lights. There is a pedestrian light which can show either stop or go for a pedestrian. And there is a push button which the pedestrian can push to request safe crossing of the street. So this sample is set up to not build from inside here, because that's also some question we've got that people would like sometimes to not build but only generate the code from model real-time and then use another IDE for building it. And in this case, I will use the Qt Creator IDE that comes with the Qt toolset. And here I have created a project that, by the way, also is in that GitHub repo. And here I have the generated files are just added as reference here under these header and source folders. And then in addition, I've written a few files here that implements the user interface for this Qt application. And what is special when you integrate with a UI application is that the main thread typically is reserved for UI work. So here, for example, we are launching a main window and then we are just running that window here. And this call will not return until the user closes that window. So obviously this makes it problematic to let the main function also drive the top capsule, which otherwise is the default. So the way this works is that in this sample is that in the main window constructor, we are creating a Qt thread and starting it here. And this thread is what we are going to run the real-time part of the application with. And then we're also using the feature in Qt called signals and slots. And that is a mechanism that allows a thread to emit a signal, and then that can then trigger the invocation of a function bound to a slot. And that does not happen in the same thread, but it happens in the thread to which this has been bound. So it's implemented as posting a message in the event queue of the UI in this case, and then when that event is handled by the UI queue, it will call this function, and that can then safely update the UI without any threading issues. And that is the mechanism how we are letting the real-time application change the UI when these lights change. And then if we look at the main function of the thread, that's where we are calling into the entry point of the real-time application. And the real-time application can, of course, launch additional threads if needed, but in this case, it just uses this thread for running it fully. So if we start this application, it will now first start up in a mode where it waits for attaching on the model debugger to this port. So let's do that. One, two, three, four, five. We'll switch here to the model debugger and we let it run. And when we start it, now this UI becomes responsive and it starts to circle the light here. So we can see here, if we open the state machine for the traffic lights, we can see that it is in the cycle light right now, where it circulates between the red, green and yellow lights. And then when we push this button, the state machine goes to pedestrian crossing. That turns the pedestrian light to go, and then after a while it goes back and starts to cycle again. So the UI, as I said, is updated using these slots and signals from Qt. But here is an example. This button is an example of communication in the other direction, where the UI needs to invoke an event in the real-time application. And the way that works is just if I terminate this, close it down. It works in the same way as we recommend for communicating from external threads by means of an external port. So this push button, I think it was visible here. Yeah, the push button has an external port which this thread, the UI thread, can use without any threading issues, since that is safe to use from a different thread than that runs the capsule. So that shows the communication in both directions with a user interface. And of course, the same principle applies for any other application where the main thread happened to be blocked by some other activity, so you cannot use it for your real-time application. Any questions on the first demo? If not, let's look at the second. Yeah?
Just a question. I'm not got it. How the signal is sent it to the Qt from the state machine.
Yes. So if we open this state machine diagram, we see that all events that it receives from the real-time application, it has to delegate to the Qt UI, and it does that by it has a handle to this thread, and then it calls because this is safe, right, because this is the thread that also runs this capsule.
Yes.
And then it calls this red light, which will emit the Qt signal that we bound to the slot that will update the red color on the UI.
Okay.
So each of these are bound to a Qt signal. Will lead to the sending of a Qt signal, which then will invoke a slot in the UI thread.
Yeah. Okay. Yeah.